Sine law applications. Question 9. Two ships A and B with underwater sonar have located the wreckage W of an old ship on the sea floor. When the distance AB between the ships is 8 km, the angles of depression to the wreck are angle A 56 degrees and for B is 19 degrees. If the sonar bearing from both ships is due west, determine the depth of water above the wreck to the nearest meter. So let's think that this is the level and we have two ships here. So let's say that the ships are located at these two places, right? And the distance between the ships is given to us as 8 km. Distance A and B. So this is A for us and this is B, and the distance between them is 8 kilometers, right? That is the distance. Now it says that the angle of depression to the wreck are for A 56 degrees and for B it is 19 degrees. So let's say that this is angle of depression of 56 degrees and from here it is 19 degrees. So let's say this is kind of like this, right? And so we have wreck here W, and let's assume that that is the sea floor. Correct? So that is kind of a picture we have. Now, angle of depression is always with the horizontal. So this angle is 56 for us for A, and that angle is 19 degrees for us, right? So we know this side, we know that angle, and with this, if this is 56, we can also find what this angle is, correct? So we know actually all the three angles in this case. So you can use sine law for sure. Now, so this angle is 56 minus 180, or you can also find that angle because this is an exterior angle, correct? So exterior angle is sum of these two angles, and therefore this angle will be, let us say, what is this? 56 minus 19 is equal to 37 degrees. So this angle should be 37 degrees, correct? So what we have used here is that the exterior angle is sum of remote interior angles. So you can use that. Or what you can do is you can find that angle to be 180 minus 56. You can both do either way. 180 minus 56 is equal to 124. Then you find, let me write it, different ink first here. So this angle is 124 degrees, and then you can say 180 minus 124 minus 19. You will get the same result as 37 degrees. Correct? So that's the diagram we have here. Correct? Now, in any case, if the sonar bearing from this determine the depth of the water above the wreck to the nearest meter, what we really want to find is depth of the water. That means we are interested in finding this height h. Okay? To find height, we need to find one of these sides. Once we know these sides, then it is easy for us to find the height. Correct? We'll use again sine law. So let's use sine law and figure out one of the sides. So let's find this side, which is AW, right? So we can write sine law as AW divided by the angle opposite to AW is 19 degrees. Sine of 19 degrees is equal to the known side of 8 kilometers over the angle opposite to 8, which is 37. This is sine of 37 degrees, right? So from here, AW is equals to 8 times sine of 19 degrees divided by sine of 37 degrees, correct? So we can calculate this and find. So we have sine of 19 degrees divided by sine of 37 degrees. We'll multiply that by 8 and we get 4.3278. So we get 4.32, let's say 8, right? So that is AW for us. Now when we know AW, then we know this side is, this is right angle, and this, we just calculated that this is equals to 4.328, right? Right. Now once we know this angle of 56 and that side, we can find what that opposite side AH is, correct? So let's figure that out. We can say sine of 56 is equal to opposite over hypotenuse, which is h over 4.328, and therefore height is equals to 4.328 times sine of 56, and that is equals to, we'll multiply this by sine of 56 and we get 3.587, 3.588, right? That's approximate height in kilometers, correct? So determine direct to the nearest meter, right? So this is equal to, this is 3 will multiply by 1000, so that is in kilometers, right? In meters, 3588 meters. So that is our answer. Our answer is, the height is, or rather depth in this case, correct? So depth is 3588 meters of the wreck, correct? So that's how we are going to solve this question. Thank you.